Create sheet metal parts. In this video, we'll create a flange, a bend, use fold and unfold, and create a flat pattern. In Fusion 360, we want to get started with the supplied dataset sheet metal lever. This contains a single body, and we're going to be creating a sheet metal lever that will attach to the area with this D-shaped extrude. To get started, we first want to understand that sheet metal components can be designed in Fusion 360, but there are some requirements that we need to make sure that we do. The first of which is that a sheet metal part is going to be its own component. Now, this can be done by creating a new empty component as a sheet metal component, or it'll be automatically done when we use our first sheet metal tool. I'm going to start by going to Assemble and creating a new component, and I want to make sure that the component is set to sheet metal. It's going to be internal. I'm going to rename component to be handle, and then I can determine which sheet metal rule I want to use. For this example, I'm going to use this steel millimeter default, and we're going to modify those parameters later. Once I do that, my design now contains handle 1 component, and you'll notice that the radio button is active, meaning we're currently working inside of this component. If we expand it, I have my sheet metal rules, and I can modify these values by switching the rules to another value, or I can navigate to my sheet metal tab, I can go to modify, and I can take a look at my sheet metal rules. Right now we have in this design and the thickness value of 2.5 millimeters. In the library, we have our steel default. Notice on the right hand side, we can edit the rule or we can create a new rule based on this. I'm going to create a new rule based on this, and instead of simply creating a copy of the original, I'm going to just put 3 millimeters in the title. Then I'm going to change the thickness value to be 3 millimeters. And I want to note that we have a couple other things that we can change, but we will leave as default for this example. We can modify things like the K factor and the way that the miter, rip, and seam gap is calculated. The K factor will determine the position of the bend internal to the sheet metal thickness. In most cases, that K factor value will be 0.44, meaning it's a little bit closer to the inside bend than the outside bend. We're going to save that, and we're going to close. Then we'll modify our sheet metal to include the new sheet metal value that we created. We'll select steel 3 millimeters, and you can see now our rule is going to create all of our sheet metal components as 3 millimeter thick steel. From here, we're going to start by creating a sketch. When I select sketch, I want to select my XZ plane for this example, and then I'm going to slowly rotate, go to create, project include, and intersect. I'm going to bring in this face just as a reference, then go back to my front view. While it isn't strictly needed, it can be helpful to have that reference in place. So I'm going to start with a line. I'm going to begin dragging this up. I'm going to slowly pan, drag this up and to the right, place, and once I have those 3 sketch entities, I'm going to hit escape to get off my line tool. Next, we'll begin with dimensions, and I'm going to go from this upper point to this point on the vertical line and make that a distance of 35 millimeters. I'm going to make the angle between these two 50 degrees. And I want to make the overall height from the center of the shaft to this upper point a distance of 165 millimeters. And I also want to have a 5-degree angle on this edge. There are a few other things that we need in order to fully define this, and one of those things could be the distance between this point and this point horizontally. In our case, I'll set that to 35 millimeters, and this will give us a fully defined sketch. When we're creating sheet metal parts, the initial sketch for the flange can either be a closed profile sketch, or it can be an open profile like we've drawn here. There are some differences, and when we create sheet metal components like this, what we're actually doing is creating a thickness based off of that line. So when we go to create and select flange, and we select the sketch, we begin dragging it, noting that it creates that 3 millimeter thick part based on the position of that line. We can choose which side that goes to, or have it be symmetric based on our sketched line. In our case, it's going to be side 1, and the direction is going to be symmetric. In our case, we're going to set this distance value to 10 millimeters, and this will be wide enough for the flange that we're mounting to. We're going to say OK, and now we've begun by creating that sheet metal component. Next, I want to use my Modify Fillet tool, and I want to create a fillet on each of these edges. I'm going to select the bottom ones as well. And note that we have an option to use a fillet full round. If we use full round, it allows us to select specific faces. And in this case, you'll notice that as I go through the selection, different selections will give me different fillets. So when we're creating these full round fillets, we need to make sure that it works in our specific instance. For this example, since I'm creating a sheet metal part and I want to fillet the top and bottom edges at the same time, I'm going to add a manual fillet, and it's not going to be a full round. I'm going to add a value of 5 millimeters to simply round off those corners. The next thing I need to do is remove this D-shaped area from the center of my sheet metal part. This can be done by creating a sketch based off of that face. To do this, I'm going to hide my sheet metal body temporarily, and I'm going to start a new sketch on the face of this part. We're going to right-click and use Create Sketch. This will automatically give us that inside profile. And one of the reasons that we're not doing this based on the face selection is because that face has a hole in the center of it. We can bring back the body, and we can use Extrude, holding down the left mouse button, looking for that profile. We can begin to drag it and set the distance through all, and noting that objects to cut, we want to make sure that we exclude the original body and we're only removing it from our handle. Now that we've removed that geometry, it gives us a way to mount our sheet metal handle onto that existing shaft. Any changes we make earlier in the design will be parametrically updated and won't affect that extrude cut. The next thing that we want to do is we want to create a cut that goes through the center of the handle. In order to do that, we need to unfold and fold the design. We can simply create a sketch in an extrude cut, but because the handle is at an angle, the cut edges will not stay normal to the direction of the sheet metal. This means that it can be problematic to fabricate. So we're going to go to Modify, and we're going to select Unfold. When we do this, we need to select our stationary entity, which will be this portion of the design, and notice that it automatically collects those bends. We're going to unfold all bends, and we're going to say OK. Next, from a right view, I want to create a new sketch, and I'm going to start by selecting this face and creating that sketch. I'm going to use my Create, and I'm going to select a sketch slot. I'm going to use center to center. I'm simply going to drag it down, begin dragging the diameter, and then I want to use some constraints. I'm going to set this endpoint vertical with the origin, and then using my dimension tool, I'm going to give it an overall height of 125 millimeters. I'm going to give it a distance from the origin of 35 millimeters. And I want to give it a radius or a diameter value. In this case, I'm going to set the radius to 5 millimeters, and then we'll finish the sketch. Use Extrude to remove this, and make sure that we cut all the way through this part. Once again, we want to double check our objects to cut to make sure we're not removing from any other geometry. And to make sure that this can update easily, I'm going to select Through All in case I change the thickness of the sheet metal part later. Now that we've created that cut and we know that all of the sides of the cut are normal, we can refold those faces. So this is a great way for us to create this complex geometry, knowing that it can be manufactured later. There are many other things that we can do with sheet metal parts, such as use that create flanges and bends to create more complex sheet metal parts. But the last step that we're going to explore is something called a flat pattern. The flat pattern is the next stage in creating a detailed drawing or exporting this for manufacture. So under the Create dropdown, we want to make sure that we create a flat pattern. Once again, we need to select a stationary face, and we'll say OK. A flat pattern is generated, and it gives us the position of the bends as well as the internal and external bend lines. We can select Export as a DXF from here, or we can even select this right-click, and create a new detailed drawing of this flat pattern. Once we finish the flat pattern, now we can see that it is included in the browser and we can activate it at any time. Some of the things that we did, such as creating the extrude cut, could be done at the flat pattern stage. But if you want to see them in the bent design, you want to make sure that you use the option to unfold and refold those designs. From here, I'm going to activate the top level of this design and go back to a home view. Then I want to make sure that I save this before moving on.